Hi, welcome back to example 2. We're now going to look at part C. Okay, part C is a little bit unique in the sense that our zeros that are given are in an exact form. So I don't know if you remember doing quadratic formula and then seeing your final solutions for x in an exact form like this. So I encourage you guys not to put this in your calculator and get an approximate answer, but if you just leave it simplified, these are now in an exact form. So if we were given these zeros that are in exact form, and we know that the quadratic contains this point, can we get our equation in standard form? Okay, let's go ahead and let's try this. So let's start with our general equation. Okay, in factored form. And I recognize that this will be my first zero, and this will be my second zero. Okay, so don't look at this and go, oh, my one zero is 3, my other one's root 5. That's not what this means. This number right here is the first zero, and this full number is the second one. Okay. All right, so I'm going to do this one a little bit differently. I'm not going to sub everything in like we normally do into the first line to find A. I'm going to take my time a little bit with it. So all that I'm going to do is I'm just going to plug in the zeros. So we'll substitute in the zeros. Okay, so we'll leave f of x as f of x and A. And here's my first zero. I'm going to put it in a bracket, right? Because it's minus the zero, and I want to subtract this whole zero. So I'm going to put it in a bracket, 3 plus root 5. Okay, now I can close the bracket. It's going to make those a bit bigger. And then do the same for the next one. Okay, so now you might be looking at this and going, wow, this is kind of looks a little complicated. So, and it is, but we can actually clean it up. We can actually clean it up quite well. So what we're going to do is we're going to take this negative and we're going to distribute it into the bracket. That way, we're going to drop that inside bracket that we don't need anymore. So we would have A times x minus 3 minus root 5, close bracket. Okay, so remember, we're taking the negative 1 and we're multiplying it in. So negative 3 here, and then negative 1 times root 5 gives us negative root 5. Okay. All right, and the same for the next one. We'll have x minus root 3 plus root 5. Okay, the shortcut for this is whenever you have a negative bracket, just change the sign on all the terms on the inside. Okay, and then drop the bracket. All right, so this is actually a little bit better, and you might not agree with me, but maybe I can convince you. So this here looks a little bit special. So it looks special in the sense that I can see a nice pattern here. So maybe if you want to pause the video and see if you could try to figure out that pattern with this, go ahead and do so. Okay, so here is the pattern. So if you did pause the video, welcome back. This is the pattern. I'm going to look at this as my first term, here and here. Okay, so those underlined in green are the first term. And then this is my last term, the root 5. Okay. So notice there's a pattern here. It goes, the greens are identical, the reds are identical, and it goes green minus red times green plus red. Okay. This is called, and maybe you might have guessed it now, it's called the difference of squares. And whenever we are doing FOIL with difference of squares, so if we want to multiply this through, okay, there's the shortcut. We don't have to do all of that. we can actually write it like this. So when I say it's difference of squares, what I'm referring to is when something's in the form a minus b times a plus b, when you expand it, you just get a squared minus b squared. Okay, so this is like my a, and this is like the b, right? So we have a minus b, and then we have a plus b. So this is difference of squares, and this is just equal to this. So it's just going to be this term squared. So I'm going to go ahead, I'm going to write that down. We have a times, and I'm going to keep this all in a bracket. So if you think of this as my a, we're going to have an a squared. So I'm just going to have x minus 3 squared. Okay. Then I have minus, and then b squared. Well, root 5, if I square that, that's actually just going to work out to 5. So this cleaned up really nice. I did have to put this round bracket around all this because this here is this, okay? And we have a multiplied by this, so I want to make sure the a gets multiplied by everything, okay? If I didn't have the brackets, it would look like a is just multiplied by the first term, and then this last part would just be floating, okay? So we do need these brackets. So we're going to clean this up a bit. So x minus 3 squared, that's going to work out to x squared minus 6x plus 9. Okay, you've probably done that one enough where you can recognize this. If not, just write them out. X minus 3 times x minus 3, and then do your FOIL for all of it. Okay, and you'll get this here. All right, the last term, the square root of 5 squared. Well, that square is gonna cancel out the root, and we're just gonna get 5. So we'll have minus 5. Close the bracket. Okay, this actually worked out quite nice, didn't it? So we have x squared minus 6x. 9 minus 5 is plus 4. Okay, now that I've cleaned this up, I would now like to substitute in my x and y. That way I can find a. That's the goal of this, right? To figure out a, and then I can rewrite the equation. Notice by doing all this, I've already kind of put it like in a standard form too as well. So this will be really easy after we get a. Okay, so we're going to sub in x and y. So negative 12's got to go in for f of x. That'll be right here. And x is 2, I believe. Yeah, so we're going to have 2 squared minus 6 times 2 plus 4. Okay, I put those in brackets just to show their substitution. So we have negative 12 equals a times 4 minus 12 plus 4. So 8 minus 12 is going to be negative 4. So we have negative 12 equals a times negative 4. Divide out the negative 4 from both sides, and a is equal to 3. So yeah, this is almost finished. Just going to give myself a little more space. So this means my function looks like 3 times x squared minus 6x plus 4, okay? So I plugged it into this line right here because this is my f of x and it's already cleaned up. So now that I found a, I just plug it into there for a, okay? And I can easily just distribute this through and get my final quadratic. So we'll have 3x squared minus 18x plus 12. So this is the equation for the specific quadratic that has these ugly zeros and passes through this point, okay? And notice I got a nice clean function, okay? I got a nice clean function because I kept everything in the exact form, and I didn't panic, and I just kind of worked with what we had. So um, yeah, that is how we handle those kind of zeros. Okay, I'll see you in the next video.